I'm going to solve the first order ODE, y prime plus 10y is equals to minus t, subject to y not equals to 0, using the Laplace transform method. So we are given that first order ODE, or the Laplace transform method, we take Laplace transforms on both sides of the ODE, so that we have the Laplace transform of y prime plus 10y is equals to minus t. And then we can go on and use properties of Laplace transforms, and it will be the Laplace transform of y prime plus 10 multiplied by the Laplace transform of y is equals to minus the Laplace transform of t. And then from the table of Laplace transforms, we can get the Laplace transform of y prime there, and that is s multiplied by y minus y naught, and then plus 10y. And then on the right hand side, the Laplace transform of t there, that's 1 factorial over s squared. So on the right hand side, we'd have minus 1 factorial over s squared. So that's the equation that we have now. But we are given this initial condition, y naught is equals to 0. We can substitute it on this part here, so it will be a 0 there. And this 1 factorial is just a 1, so that our equation becomes s multiplied by y plus 10y is equals to minus 1 divided by s squared. But here we can factor this y, so that our equation becomes y multiplied by s plus 10 is equals to minus 1 over s squared. And the next step is to make y subject of the formula. So if we make y subject of the formula there, what we get is y is equals to minus 1 divided by s squared multiplied by s plus 10. So that's the equation that we have now. But for us to get a solution, we need to evaluate the inverse Laplace transform of this y that you've just obtained. But from our table of Laplace transforms, we don't have a function of this form here. So what we have to do there is we have to rewrite this function using partial fractions. So using partial fractions, what we have there is minus 1 over s squared multiplied by s plus 10. It will give us minus a over s, and then minus b over s squared, and then minus c over s plus 10. Then when we put everything under a common denominator there, what we would have there is minus as multiplied by s plus 10 minus b times s plus 10 minus c times s squared. Then when you compare these two numerators, we'll get the values of the a, the b, and the c. So we'll get that our a there is 1 over 100. It's a minus 1 over 100 there. Then our b is equals to 1 over 10. Then our c is equals to 1 over 100. Then substitute them on this part here, so that would have our y there is 1 over 100s minus 1 over 10 times s squared minus 1 over 100s times 10. So that's the equation that we now have. To get our solution y, we have to take inverse Laplace transforms. So our y, which is the lowercase y, the y of t is equals to the inverse Laplace transform of y, which is equals to the inverse Laplace transform of the expression that we have just written here. So that our expression there will then become the inverse Laplace transform of 1 over 100s minus the inverse Laplace transform of 1 over 10s squared minus the inverse Laplace transform of 1 divided by 100 multiplied by s plus 10. And this is by properties of Laplace transforms. Then we can take out these constants, so that we would have 1 over 100 multiplied by the inverse Laplace transform of 1 over s minus 1 over 100 multiplied by the inverse Laplace transform of 1 over s squared minus 1 over 100 multiplied by the inverse Laplace transform of 1 over s plus 10. And then we go on and find the Laplace transforms from the table of Laplace transforms. The inverse of 1 over s, it gives us a 1. And the inverse of 1 over s squared, that's a t. The inverse of 1 over s plus 10 gives us an exponent of minus 10t. So that our solution there becomes 1 over 100 minus t over minus 1 over 100 times exponent of minus 10t. So that's the solution that we are having. So what we are saying there is the solution of the first order ODE is y of t is equals to 1 divided by 100 minus t minus 1 over 100 multiplied by exponent of 10t. And this t here is saying that y is a function of t. So that's our solution there.